Greetings, namaste, and welcome back. I'm Dr. Naresh Bana, and I'm with you with yet another excellent video which will not only give you basic knowledge of green hydrogen but also its utilization for public private partnerships. And I'll also show you the largest project, the green hydrogen project of the world. So continue watching. And we all know that hydrogen is in news, and because the green hydrogen is the cleanest sustainable energy source and it can play a crucial role in reducing greenhouse gas emissions, we also know that it's becoming more and more economically viable and sustainable, and this ecosystem lends itself very well for the public private partnership format of project development. You may also like to know that it is green hydrogen which packs 142 megajoules of energy per kilogram. It is the cleanest fuel with zero greenhouse gas emissions, and it can have diverse domestic sources. It's economically competitive, and it has better safety and security than many other commercial fuels, and it is faster in refueling than the counterparts in EV battery system. Now, what is green hydrogen? What is green hydrogen and how is it produced? In order to combat climate change, we need to adopt electrification as a clean and sustainable solution to many of our transportation and industrial needs. Today, we generate the majority of electricity from sustainable sources such as wind and solar, but these sources sometimes struggle to fuel industry and larger heavy industry installations because these are not continuous. That's where green hydrogen comes in. We have also heard that there are various colors of hydrogen. What are these? These are essentially to differentiate between how the hydrogen is produced and what kind of energy source is used and what is the climate neutrality of any such hydrogen. So let me introduce firstly the gray hydrogen. It is produced by using shock wave reforming of natural gas, and since carbon is produced alongside, so it's called gray hydrogen. And when in a similar process by autothermal reforming, the carbon is captured, part of it, then it's called blue hydrogen. And if it is produced using electrolysis, it's called green hydrogen. And if it is using the gasification of coal, it is black hydrogen. And when you are using nuclear energy, then it's called pink hydrogen. And when pyrolysis is used to produce green hydrogen, then it is called turquoise hydrogen. And the solar energy produced hydrogen is called yellow hydrogen. The recommended strategies for countries for energy transition: firstly, they should encourage public private partnership framework because the entire green hydrogen ecosystem lends itself well for investment through PPP mode. There should be assurance for purchase of output, and the storage itself could be offered in public private partnership with a safe and secure norms built into it. Then concession agreement should be finalized. The model concession agreements and the transparent PPP procurements should be set up. There should be incentives for manufacturing of electrolyzers. Now, when we talk of electrolyzers, let me show you how they work. Electrolysis involves separating hydrogen and oxygen with help of electricity. When the direct current DC is passed through water, oxygen appears at positive, that is at anode, while hydrogen is released at cathode. In volume, hydrogen is twice the volume of oxygen released. As you know, pure water is not a good conductor, so the salt is added, which is not environmental friendly solution. So the use of proton exchange membrane PEM is possible to extract hydrogen from pure water as the membrane provides necessary transport for particles to pass through between anode and cathode. Now, There are places where green hydrogen cannot be used. In these areas, green hydrogen derivatives can be used, where green hydrogen is used as a feedstock to produce these derivatives. And such derivatives are green ammonia, green methanol, and sustainable aviation fuel, which are self explanatory. Only thing is, methanol is rapidly gaining acceptance as fuel for shipping. As BCG has put up their graph, there are huge investment and business opportunities. Like, the cost of production of green hydrogen today ranges from $4 to 7.5 per kilogram, which with innovations needs to be brought down. There is a huge opportunity for investment of public and private capital in this comparatively less risky green hydrogen production and storage and entire ecosystem or electrolyzers. It may attract large amount of foreign investment as well in emerging economies, and it may thereby help and boost domestic capital markets. These are some of the pictures from the uh, green steel industry of Sweden. And now let me show you the largest project, the green hydrogen producing project of the world. NEOM Green Hydrogen Project, Saudi Arabia. The NEOM Green Hydrogen Project is the world's largest utility scale, commercial based hydrogen facility powered entirely by renewable energy. The engineering, procurement, and construction contract has been awarded to an Indian company, Larsen and Toubro. When commissioned, it will produce 600 metric tons per day of clean hydrogen by electrolysis using ThyssenKrupp technology, and will also produce nitrogen by air separation using air products technology. And for completing this video, I must give credits to Scottish Power, OMV, and Renewed Energy, from where I have referred to their videos and taken some help. With that, I come to the end of today's this video log, and I'm sure you have liked it. You may like to share and subscribe. You can continue watching till I come back with yet another good one for you. Till then, keep viewing. Thank you. Namaste and have a good day.